HID lighting capacitors can fail, often exhibiting a telltale sign of goo leaking from their case. This goo is typically the capacitor's internal electrolyte, a viscous, oily liquid that can vary in color. The leakage is a result of a breach in the capacitor's internal seal. Several factors can contribute to seal failure, including lightning strikes, power surges, or simply the capacitor's age. When the seal is compromised, the electrolyte escapes, potentially through a small hole in the capacitor's case or through the terminals. If you observe this goo on an HID lighting capacitor, immediate replacement is crucial. A failing capacitor can lead to flickering or complete lamp failure, and more seriously, it presents a fire hazard. Replacing an HID lighting capacitor requires careful attention to safety. Firstly, always ensure that the power to the light fixture is completely turned off before commencing any work. Secondly, discharge the capacitor before handling it. This can be achieved by carefully touching the terminals together using an insulated screwdriver or another metal object. This step is essential to prevent electric shock from any residual charge stored in the capacitor. Thirdly, remove the old capacitor and install the new one in its place. Pay close attention to the capacitor's polarity. The positive terminal of the capacitor must be connected to the positive terminal of the power supply, and the negative terminal to the negative terminal. Incorrect connections can damage the capacitor or the lighting fixture. Finally, after completing the replacement, turn the power back on and thoroughly test the light fixture to ensure proper operation. The role of the capacitor in an HID lighting system is multifaceted. In many HID circuits, the capacitor serves as a power factor correction component. Power factor is a measure of how efficiently electrical power is used. A low power factor indicates that a significant portion of the current is reactive, meaning it does not contribute to the actual work done by the lamp. This reactive current increases the overall current draw on the system, leading to higher energy bills and potentially overloading the electrical infrastructure. The capacitor corrects the power factor by providing a leading reactive current that offsets the lagging reactive current of the inductive ballast. This brings the power factor closer to unity, meaning the current and voltage are more in phase, resulting in more efficient power utilization. In some HID lighting circuits, the capacitor can also be part of the starting circuit, assisting in providing the initial voltage surge needed to ignite the arc within the HID lamp. HID lamps require a high voltage pulse to initiate the arc discharge. The capacitor, in conjunction with other components in the starting circuit, helps to generate this high voltage pulse. There are several types of capacitors used in HID lighting applications. These include film capacitors, electrolytic capacitors, and ceramic capacitors. Film capacitors are known for their reliability and long lifespan, making them a popular choice for HID lighting ballasts. Electrolytic capacitors offer high capacitance values in a compact size, but they are generally more susceptible to failure due to heat and voltage stress. Ceramic capacitors are often used in high-frequency circuits due to their low equivalent series resistance. When selecting a replacement capacitor, it is essential to choose one with the correct capacitance value, voltage rating, and temperature rating. The capacitance value, measured in microfarads, must match the original capacitor's value to ensure proper power factor correction and starting performance. The voltage rating of the capacitor must be higher than the maximum voltage it will be subjected to in the circuit. This provides a safety margin and prevents the capacitor from breaking down under high voltage conditions. The temperature rating of the capacitor specifies the maximum ambient temperature at which the capacitor can operate reliably. Choose a capacitor with a temperature rating that is appropriate for the operating environment of the light fixture. When troubleshooting HID lighting systems, a bulging capacitor with leaking goo is a clear indication of failure. However, capacitors can also fail without any visible signs of damage. In such cases, it is necessary to use a multimeter to measure the capacitor's capacitance and equivalent series resistance. A significant deviation from the specified capacitance value or a high equivalent series resistance indicates that the capacitor is faulty and needs to be replaced. Power surges are a common cause of capacitor failure in HID lighting systems. Power surges are transient overvoltage events that can occur due to lightning strikes, utility switching, or other disturbances in the electrical grid. These surges can subject the capacitor to excessive voltage stress, leading to insulation breakdown and eventual failure. To protect HID lighting systems from power surges, it is recommended to install surge protection devices. Surge protection devices divert the excess voltage away from sensitive electronic components, such as capacitors, preventing them from being damaged. Regular maintenance is essential for ensuring the long-term reliability of HID lighting systems. This includes inspecting the capacitors for any signs of damage, such as bulging, leaking, or discoloration. It also includes checking the voltage and current levels in the circuit to ensure that they are within the specified operating range. Furthermore, it is crucial to keep the light fixtures clean and free from dust and debris, as this can help to prevent overheating and extend the lifespan of the components. When disposing of failed HID lighting capacitors, it is important to follow proper environmental regulations. Capacitors may contain hazardous materials such as electrolytes that can contaminate the environment if not disposed of properly. Check with your local waste management authority for guidance on how to dispose of capacitors safely and responsibly. Understanding the function and failure modes of HID lighting capacitors is essential for anyone involved in the maintenance and repair of these systems. By following the safety precautions and maintenance procedures outlined above, you can ensure the reliable and efficient operation of HID lighting systems and prevent potential hazards. The bulging and goo are telltale signs. It's important to understand the circuit and capacitor properties. Power factor correction contributes to energy savings. Surge protection devices protect from overvoltage. Regular inspections and maintenance contribute to reliability. Safe disposal protects the environment. Correct capacitance values and ratings matter when replacing. Electrolytic capacitors fail to high voltage and heat. When using a multimeter, look for deviations from specifications. Always disconnect power before any work. Properly connect the new capacitor. Consider a film capacitor replacement for reliability. The capacitor can also be part of the starting circuit. A high voltage pole starts the arc discharge. If the capacitor has goo, replace it immediately. Make sure it is the correct microfarad. Also make sure to choose a voltage that is appropriate for the circuit. A bad capacitor can cause flickering. It is more dangerous than just flickering. It can also cause a fire hazard. You also want to be aware of the temperature ratings when choosing a replacement. The most common type of failure is power surges.